Math 1143, Section 3.2, Exponential Functions, Objective 4. Use exponential functions in applications. In the first one, an investment of $4,096 loses 1/2 its value every 3 years. Find a formula for its value after t years. Okay, so we'll list a column for the year and another column for the value. So at year 0, the value of the investment is $4,096. But we're told that it loses 1/2 of its value every 3 years. So after 3 years, the value of this initial investment will be 1/2 of that, or $2,048. At the end of 3 more years, 6 years, the value will be 1/2 of 2,048, which is 1,024. And after 3 more years, the value, at the end of 9 years, the value will be $512. And we wanted to see if we can figure out a formula for this. Well, notice after 3 years, 2048 is 4,096 times 1/2. And after 6 years, this value is 4,096 times 1/4, which is 1/2 to the second. And after 9 years, 512 is 4,096 times 1/2 to the third. Okay, so if we do that for year 0, well, let's look at this one first. When t is 3 years, we can think of 1/2 as 1/2 to the first. And when t is 0 years, 4,096 is 4,096 times 1/2 to the 0, because 1/2 to the 0 is 1. Okay, so what we'll do is note a couple of things. When the value of t years is 3, the exponent is 1. So think of this as 4,096 times 1/2 to the 3 over 3, because 3 over 3 is 1. And then after 6 years, this exponent on 1/2 is 2. So think of this as 4,096 times 1/2 to the 6 over 3, because 6 over 3 is 2. And then for this one, after 9 years, the value of the investment is 4,096 times 1/2 to the 9 divided by 3. 9 divided by 3 is 3. So you can see a pattern. At the end of t years, the value of the investment will be 4,096 times 1/2 to the exponent t divided by 3. And you can verify that this formula works just by plugging in the values of t that we already know. Okay, in the next example, this time an investment of $3 doubles every 5 years. Find a formula for its value after t years. Okay, so we'll do the same sort of thing. we'll start with year 0 and then the value. We're starting with a value of $3 when we start out, and then 5 years later, this value doubles, so it's now 6. But think of 6 as 3 times 2. Then after 5 more years, the value of the investment is $12. But think of 12 as 3 times 2 to the second. 2 to the second is 4, and 3 times 4 is 12. After 15 years, the value doubles again to 24. But think of 24 as 3 times 2 to the third. And we'll do one more, and then we'll observe the pattern. After 20 years, the value of the investment will be 2 times 24, or 48. But think of 48 as 3 times 2 to the fourth. 2 to the fourth is 16, and 3 times 16 is 48. Okay, so we'll go back up here. 2 is 2 to the first. At year 0, 3 is 3 times 2 to the 0, because 2 to the 0 is 1. Okay, so we can take note. We'll start with this one. When t is 5 years, the exponent on the base number 2 is 1. So think of this as 3 times 2 to the 5 divided by 5. 5 divided by 5 is 1. In this example, when t is 10, the exponent is 2. So this is 3 times 2 to the 10 divided by 5. 10 is the number of years. And then when t is 15 years, this is 3 times 2 to the 15 divided by 5. And verify 15 divided by 5 is 3. Well, no doubt you see the pattern, but we'll keep going one more. When t is 20, think of 3 times 2 to the fourth as 3 times 2 to the 20 divided by 5. 20 divided by 5 is 4. Okay, so after t years, the value of the investment will be 3 times 2 to the t divided by 5. And then you can go back and verify that this formula works for each of those t values that we already tested. Okay, another problem. An exponential function has the form y equals a times b to the x, where b is greater than 0 and not equal to 1. So if the graph of this function passes through the points 136 and 39, find the values of a and b. Okay, so this is a formula for finding points on the graph. So we're told that in one case, when x equals 1, the y value is 36. Okay, so we'll replace y with 36, and that's equal to a times b to the exponent 1. So in other words, 36 equals a times b, because the exponent is just 1. And then we're told that when x equals 3, the y value is 9. So in the function, replace y with 9 and replace x with 3, we get 9 equals a times b to the third. So we're going to use these two equations and determine what the values of a and b are. There's a number of ways to go about it, but one way is just solve for the easiest variable in both it looks like it's easier to solve each equation for A. So A is equal to 36 divided by B. And for this one, A is equal to 9 divided by B to the third. So that must mean that 36 over B is equal to 9 over B to the third. And then you remember, whenever two fractions are equal, the cross products are equal. So this is a long way to do it, but we can use cross products are equal. One cross product is 36 times B to the third. That's equal to the other cross product, 9 times B. And then divide both sides by B, or why don't we just divide both sides by 9B, and we get 4B to the second equals 1. And then divide both sides by 4, B squared equals 1/4. And we're told that B has to be positive, so the positive solution to this is B equals 1/2. Okay, and if B equals 1/2, we still need to find the value of A. So it looks like if we use this equation, A is equal to 36 divided by 1/2, and 36 divided by 1/2 is just 72. Okay, so to summarize, A is equal to 72 and B is equal to 1/2. Okay, one more problem. This time, well, it's the same sort of problem. An exponential function has the form y equals a times b to the x, where b is positive and not equal to 1. And this function passes through the points 218 and 486. Okay, so we have y equals a times b to the x. And when x is 2, y is 18. So replace y with 18 and replace x with 2. So we get 18 equals a times b to the second. And then we're told that when x is 5, the y value is 486. So now replace y with 486 and x with 5. So we get 486 equals a times b to the 5th. Okay, we can do the solve each equation for a again. A is 18 over b squared. And this one, a is equal to 486 over b to the 5th. And then set 18 over b to the second equal to 486 over b to the 5th. I think I want to do this a little bit differently this time. If I just swap this numerator with this denominator, I get b to the 5th over b to the second equals 486 divided by 18. And b to the 5th divided by b to the second is b to the third. And 486 divided by 18 is just 27. And so if b to the third is 27, b is equal to 3. And then to find a, we'll just use the easiest one. A is equal to 18 divided by 3 to the second, or 9, or 2. So a is 2 and b is 3 on that one.